It's well documented that the Arctic is warming twice as fast as the rest of the Earth. But clouds play an important role in the Arctic climate, primarily by helping to keep the region cool. Researchers at Pacific Northwest National Laboratory are experts in aerosols, or tiny particles in the atmosphere, that can affect the type and longevity of those clouds. Aerosol particles affect climate directly by scattering and absorbing sunlight. They can affect it indirectly by altering the clouds themselves. More than 80 researchers from the United States and Canada participated in the Indirect and Semi-Direct Aerosol Campaign, or ISDAC, in Alaska, to learn more about the aerosol effect on clouds. The field campaign was led by PNNL. High above the Department of Energy's Atmospheric Radiation Measurement Climate Research Facility in Barrow, aircraft outfitted with 41 specialized instruments gathered data on 27 flights.
We just end up with the cloud droplets and ice crystals coming through at the back end, and then we could evaporate those and look at the particles that the cloud droplets and ice crystals formed on. And we had instruments that could actually tell us what those particles were made of and how big they were on a particle-by-particle basis.
Thanks to ISDAC, soot particles are no longer treated as ice nuclei in our climate model. That change better reflects the cooling influence of longer-lived Arctic clouds. However, as scientists continue to refine the models, there are many additional factors to consider. For instance, soot particles do absorb sunlight, causing atmospheric warming, and greenhouse gases that also create warming are increasing.
Our hypothesis is that human activities that produce aerosol particles in the atmosphere are making clouds brighter and cooling the planet, and that's hiding some of the warming due to increasing CO2.
The field measurements collected in this campaign provide the most complete cloud and aerosol data set ever collected over the North Slope of Alaska. Because of ISDAC, we know that clouds have a huge impact on the energy balance of the Arctic. Research projects like ISDAC that increase our knowledge of aerosol particles and cloud physics are crucial to accurately representing them in climate models. PNNL researchers are developing a more comprehensive understanding of climate change on many fronts. Their studies provide a foundation to help guide policymakers as they make decisions on efforts to reduce or adapt to coming climate changes.